Scientists uncover microbes that destroy forever chemical pollutants. Little is known about the fate of PFAS, the forever chemicals in our environment, but new research finds that bacteria in wastewater can degrade specific types of forever chemicals. Certain bacteria can degrade the strong bonds that give forever chemicals their long shelf life, and this hints at potential low-cost treatments that could cleanse water of concerning PFAS. PFAS, or perfluoroalkyl and polyfluoroalkyl substances, are human-made compounds found in many products. They contain strong chemical bonds that do not easily break down, making them difficult to remove from our bodies and the environment. PFAS has even been linked to a variety of health effects, and this past April, the Environmental Protection Agency set limits on the concentration of 6 common PFAS in drinking water. This move highlighted a need for effective ways to clean up polluted waters. And now a study published July 17 in the journal Science Advances. Researchers reported for the first time that 4 species of Acetobacterium can degrade the bonds in some PFAS. This includes unsaturated PFAS, whose chemical structure makes them easier to break down than so-called saturated PFAS. Examples of these chemicals include PFMEUPA and FTMEUPA, which are not yet regulated by the EPA. PFAS degradation using microbes is one of the most sought-after technologies in wastewater treatment and waste management. Nirupam Aich, Associate Professor of Engineering at University of Nebraska-Lincoln, who was not involved in the research, said, "There are already some effective approaches to treating PFAS, including filtration and heat treatment. However, using biological approaches involving bacteria could have unique advantages. According to the study authors, the approach could be low cost and easily injected into groundwater beneath the Earth's surface, where many existing treatments are challenging to apply. Groundwater supply is about 1/3 of U.S. drinking water. The microbes highlighted in the new study break down carbon-fluorine bonds in some unsaturated PFAS, and this process, known as defluorination, is driven by enzymes that split the chemical bonds, thus releasing fluoride atoms. These atoms would usually kill bacteria, but the researchers found that the Acetobacterium species have specialized channels that pump fluoride out of their cells and into the environment, enabling the bacteria to survive. And this may be part of the defense mechanism the bacteria evolved to detoxify compounds that would otherwise kill them. Senior study author Yu-Ji Men, Associate Professor in the Department of Chemical and Environmental Engineering, University of California, Riverside, said, and after pinpointing the defluorination enzymes, the team scoured genomic databases to see if their other Acetobacterium also had the same enzymes and pumps. They found defluorinating Acetobacterium in wastewater samples from North America, Europe, and some parts of Africa and Asia. Additional clues hint that they may also be found in soil and groundwater, the study authors noted. Acetobacterium species are commonly found in wastewater, but little else is known about them and their defluorination enzymes, Men said. In previous work, Men and colleagues identified other bacteria that could break down the carbon-chlorine bonds found in some PFAS, triggering a reaction that dechlorinated and then destroyed the forever chemicals. The scientists' more recent finding adds to the number of known PFAS compounds that can be degraded and by microbes. So this is all great news, isn't it? This line of research could guide the search for more PFAS-degrading bacteria, leading to the discovery of new enzymes and the development of biotechnologies that accelerate these natural processes, Men said. Microbial degradation of PSAF usually refers to using microbes in wastewater treatments to degrade PFAS prior to the water being disinfected and returned to the drinking water supply. Ike said, "The major challenge of this approach has been the rarity of microbes that can break down the carbon-fluorine bonds. Even if microbes are able to degrade the chemicals, the rate of degradation can be slow. This study is one of the first to provide insights into the specific mechanisms and bacterial enzymes that could be isolated and improved to increase those degradation rates, Ike said. The researchers are now working on material microbe interfaces that combine the fluorination ability of bacteria with materials that enable the breakdown of PFAS, the forever chemicals. The properties of these materials change in response to electrical fields, and this enables them to destroy any byproducts left over by the bacterial enzymes, said Chong Liu, an associate professor of chemistry and biochemistry at UCLA who led the research on interfaces. And thus, material microbe interfaces provide a swift 1-2 punch to PFAS, Liu said. Moreover, and more research is needed to unpack the exact biochemistry of the defluorinated enzymes and their potential effect on large scales, Ment said. It's very unlikely that individual microbes could become a global solution to PFAS contamination, she said. Nonetheless, their work points to avenues for using bacteria in biotechnologies that could work alone or in combination with other approaches. Now, this is by Miriam Bergeret on Life Science. Please leave your comments. Thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.